Okay, so today we're continuing segments and distance, but we are doing the distance formula, 2 dimensions, which means we want to get a line segment and find its distance. So we need a right triangle here. Do you want to do it? Okay. Yes. So find the distance formula is the Pythagorean theorem. So what you want to do is you want to aim it how you would like to see it on the screen. Okay. So what is the distance formula? Well, we need to think about this. This is x1 and this is x2. And what we did here is we subtracted those two, so that's x2 minus x1. You have to square it because that's basically your change in x squared, and this is your change in y, and you want to square it, and that's your distance squared. So we need to take the square root of that, because I know that plus the difference of the y's squared is equal to the distance squared. But in order to do that, we have to take the square root. So that is the distance formula, d. Okay. So d is equal to the square root of the difference of the x squared plus the difference of the y squared. Let's find it here. First of all, 2 and -2. Which one's smaller? -2. So that's x1. This is y1. This is x2, y2. So the distance is equal to the square root of the x2, which is 2, minus a -2, square it, plus -1 minus a -1, square it. Okay, so what you have to think is like we did before. One is positive, one is negative, so that's going to add together. 2 plus 2, that's 4 squared. Plus 1 minus a -1, anything minus itself is 0, so you square it. So this becomes the square root of 4 squared, or the square root of 16, which is 4. So the distance there is 4. Your turn. Okay, so take a moment to do that. What would you do? Let's draw it. -4 and 9. Which one's smaller? -4 or 9? -4 is smaller, so that's x1. This is y1. 9. x2, y2. What I like to do is I like to put the -4 here and then think, okay, I have to get up to 9. Then 3 to 8, negative. The 3 is higher than the -8, so this is really up here. This is -4, 3, and I need to get to 9, -8. So this is the difference. How far did you drop? How far did you go over? From -4, to 9, that's 13. From -8 to 3, that's 11. So the distance is the square root of 13 squared plus 11 squared. Okay. So if you don't know what 13 squared is, 10 plus 3 times 10 and 3. 3 times 10, class? What's 3 times 10? 30. And 10 times 3 is also 30. And 10 times 10? 100. 3 times 3 is 9. 169. It's 169. Similarly, you could do 10 and 1. And 10 and 1 would be 10, 10, 100, and 1. So that's 121. Plus 121, square rooted. So 100 and 100 is 200. 69 plus 1 is 70. And 20 more would be 90. So that's 290. You could also line it up. Square root of 290. For that, that's the exact answer. I would like an approximate answer as well. So what I'm going to do is I'm going to type it here. Okay, so escape. What you want to do is you want to go to the one, you want a new document, don't save the old one. And I'm going to add a calculator, and I'm going to take the second square root. I said square root, which is here, set control square root. Why am I getting extra characters? Control the square root, and I gotta get the difference. So the formula is, in parentheses, -4 minus the minus 9, close it, square it, plus parentheses 3 minus the -8, close the parentheses and square it. So this is the way I teach the freshmen to do it. I like to do the other part myself. So this would be the way I did it. I would take the square root of 290, which you should also be able to approximate yourself. Okay, so it was 17 approximately, 17.0. Approximately 17.0. So here's the exact answer and the approximate answer. Okay. All right, let's flip the page. Here's our new objective. I will be able to determine the coordinates of the midpoint. So we did the distance segment, now we're going to do midpoints and bisectors. So I will be able to determine the coordinates of the midpoint of a segment when given the coordinates, endpoints, as represented in 1 dimension and 2 dimensions. So a point on a segment, the same distance, or a point on a segment equidistant from both endpoints. That means this point M, PM, is the same distance as QM. M is equidistant from P and Q. A point is the midpoint of the segment if the distances from the point to each endpoint are equidistant. Or in plain English, the same. Or AKA equi, which means equal, and distance means the same. Equidistant. Okay, construction. Construct the midpoint of the segment. Okay, guys, get your compass. And what I want you to do is I want you to measure this distance to go like this, yeah? And as long as it's more than halfway, you can do that. So what we're going to do is do this. And it can be smaller. It can. But whatever you do to one side, flip the sides and do it over here as well. I did one like this and one like this. Once I have those, I get my straight edge and you'll see that I can connect them. I line up the straight edge, so this point and this point are the same, this point and this point, this point and this point are the same. Usually I just do one of these, but there, this is perpendicular, and so this is the same as this. Now, that's the midpoint. Now, AM equals MB, so AM is, segment AM is congruent to segment MB, and M is the midpoint. What are the steps? Draw the circles from either endpoint and then connect the perpendicular bisector. So what's the midpoint formula? Add the coordinates, divide by 2. I'm going to write this down. Add the coordinates, divide by 2. So, find the coordinate midpoint of FG. F is at -3, so that's -3, and G is at 3, plus 3. All of this divided by 2, which is 0 divided by 2, which is 0. So here's 0, and here is the coordinate of the midpoint, right here. This is 1, 2, 3, then 1, 2, 3. It's the same distance from the endpoints. Okay, your turn to find the coordinate of the midpoint JK. So what is the coordinate of J? Class, what's the coordinate of J? Look at it. -1. So it's -1 plus, what's the coordinate of K? Class, what's the coordinate of K? So add them together and divide by 2. What's 4 minus 1? 3. And divided by 2? 1.5. So that's 1.5. This coordinate here, 1.5, is 1, 2, 3, 4, 5 halves. 1, 2, 3, 4, 5 halves from each of the endpoints. And so that is the coordinate of the midpoint. Okay, so far so good? Okay. Waiting.
What you waiting for?
For them to finish copying. When I do it on the computer, I can pause it. Here I can't because I don't think it allows it, does it? No, if I pause it, it'll stop, right? Because we're doing live. Hope this works. All right, flipping this. Okay, example 2. Okay. Are you aiming this correctly?
Yep.
Okay. Help. Switch with her, somebody.
Chicago.
Benny. You're looking through there, making sure you're taking a good picture because it's the video we're uploading. It's live. Okay. Example 2. If the coordinate of the midpoint of AB is in the line is 3, so 3, that is the midpoint. A is negative 2. So this is A. Right? Find B. So if A is here, is B going to be here, here, or over here? Section 1, 2, or 3. Where's B? On the left of this, in the middle, or the right? Okay, M is the midpoint. That's the middle. A is on the left. So that must mean that B must be somewhere over here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of these. So 10 halves is 5. So if you measure this from negative 3 to 2, that's a 5. So B's over here, but I just can't see it. So I already know the answer is 3 plus 5. I know it's 3 plus 5, which is 8. So the coordinate is 8. Now that's using geometry. Let me do some algebra. I know that it was add negative 2, it's this one, plus the one over here that I don't know where it is, call it x, divided by 2, has to be 3. Has to be 3. So this has to be 3. So how do I solve this? Well, I am going to multiply by 2. Negative 2 plus x has to equal 6, because I have to multiply by 2. And then I'm going to add the 2. So now I know that x is 8. And that's the algebra of it. Your turn. Try the quick check. Straight it up. You're looking. No, it's like this.
Well, that's how it was right now.
Yeah, but it was a little crooked, I could tell.
Yeah, you go.
All right. So what'd you get for the quick check? Let's try it. If the coordinate of the midpoint, you want to try it?
I'm good.
Okay. You want to try it? All right. If the coordinate of the midpoint of CD is the number line is 1, so you have to imagine here's C and here's D, and this is 1. The midpoint, M. Oh, let me backwards. I was putting the letters down here. So this is M, this is 1. Oh, I flipped it. That's okay. If C is a negative 3, what is this? What's negative 3 and 1? One's negative, one's positive, so you have to go through 0. That's 3 plus 1. So CM equals the absolute value of negative 3 plus the absolute value of 1, which is 4. So MD has to equal 4. So if I add 1 plus 4, that's 5. So D is at 5. That's why I do it geometrically. Algebraically, I just got to get the 1 and add the difference. Okay, let's try the midpoint formula for 2 dimensions. Coordinate system at the right. So it's the same thing. It's going to be add the coordinates verbally, comma, divide by 2. So I have an ordered pair. M is going to be at x1 plus x2, added together, divided by 2. Then on the y-axis, y1 plus y2 divided by 2. And that's my formula. Okay, find the coordinates of each given the points. Okay, -9, 3. So that means I'm going to go -9. This is your x. This is your x. This is your y. This is your y. So -9 plus the 8 divided by 2. That's -1 divided by 2. Then 3 and -7. 3 plus a -7 divided by 2. 7 take away 3. -4. -4 divided by 2. What's -4 divided by 2? -2. Let's look at it visually. Where's -9, 3? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is -9. This is -9. And this is 8 over here. Excuse me. Yeah, 8. So halfway between those two is -1/2. That's this number here, right there. -1/2 is this one right here, because that's the x's. Now let's do the y's. 3 and -7. So -7 is, this is 10, 9, 8, 7. This is y equals -7, and that's 3. 1, 2, 3. Y equals to 3. Add these together and divide by 2. It's -4 divided by 2 is -2. So this is the midpoint of the y thing. This is the midpoint, x coordinate of the midpoint. So this is your midpoint right here. At -1/2, -2. That's your midpoint. So where's the segment? This point is this point here. This point is this point here. So that's the geometry of it right there. Your turn. Try drawing this. I still have example 4 and these over here. Okay. So give me a moment to do that. What's your first step, class? What's my first step? I have to remember the formula. Or I can graph it.
1 plus x2 divided.
Add the coordinates and divide by 2. So what's 3 and 7? Add it together. Divided by 2? 5.
Hold this shit.
So
Hold this shit.
-6 and 2. What's -6 plus 2? Divided by 2. -4 divided by 2 is -2. So 1, 2, 3, 4, 5. 1, 2. That's the middle. What 2 points? 3, -6. 1, 2, 3. 1, 2, 3 down, and 3 more down. And you see this little triangle, and then again 7, 2. This is 5, 6, 7, 1, 2. So you see the rise and the run. That's these 2 points and its midpoint, which is there. So that's another way to think about it. I like to do it. Yeah. That's the coordinates there of that point there. Okay. Example 4. If M is the midpoint and A and M, where's B? So 0, 1. That's A. 3, 5. 1, 2, 3. 1, 2, 3, 4, 5. 3, 1, 2, 3, 4, 5. So measure 1, 2, 3, 4. That's 4 this way and 3 this way. So go again 4. 1, 2, 3, 4. 1, 2, 3. So if this is A, this is M, this has to be B. So the question, where is B? Well, this is a change in. Up and down is a change in Y, what floor you're on. And the change in X is 3. So to A, which is 0, 1, I have to get the change in Y was 4, so add 4 here. And on the X, add 3. So add these. And B, well, 0 plus 3, 3. 1 plus 4, 5. 1, 2, 3. Okay. Oh, from M, not from A. Sorry. You got to add it to M. And M is at 3, 5. 3 plus 3? Class, 3 plus 3? 6. 5 plus 4? 9. So that's 3, 6, and then 9. So that's B. 6, 9. Okay. Try it over here. Take your time and draw it. See how you do it. You're too far. You guys can't handle it back here. It's too slow. They gotta get closer. Folks, in order to slow the teacher down, you stop and slow down. You're still recording. You can't move
Pues,
the.
ya no nada pasando en
You
el
have
papel.
to- What happened? ¿Ya lo pagaste?
No, ya está prendido.
No, it's 22. So it's still going?
Ya estoy going.
Okay, and you can't put any of their faces on there. All right, so. Yes, ma'am. Now, go ahead. Here. And see, you can do this, like this, right? So we're going to zoom in on this one. So, like that,
Alright.
right? Put this in the frame only. Okay. First time. Okay, guys, first step. What do I graph? Paul, what's my first step? Paul? What do I do? It's on your paper on page 13. Well, read the problem. Huh? Look at somebody else's. Okay, stop right there. Everybody, on your paper, graph -1, 4. So this is your X, this is your Y. Go over 1, then 1, 2, 3, 4, put the dot. That's M. I'm not going to put the letter because I need to decide where the other part is. Okay, what are the coordinates of C? That's the question. If D is 3, -2. Let's graph 3, -2. 1, 2, 3, then 1, 2 down. And that's D. At 3, -2. You can label it. So now I know that C